Oh, yeah, I'm done. Starting with the recording. Hi, Tebu, how are you?
I'm good, thanks, and how are you, sir?
Oh, I'm good, thanks. Welcome to the today's lesson. So I think next week we'll be finishing with Euclidean geometry. If we didn't manage to finish today, we will be done. We're almost there, guys. Let me just share my screen. Welcome, Atli. How are you?
I'm good, sir.
Cheers. Share the screen. Can you all see my screen outside?
Yes, sir.
Yes.
Okay. Oh, okay. Thank you, guys. Let me quickly go to the work of today. So, since with our previous lessons, we have been doing the properties of the parallelogram as a quadrilateral, and then now we are able to apply the properties of a palm to calculate whatever we are required to calculate or to prove that the quadrilateral is a palm. Now we are going to look at the rectangle, square, trapezium, and the kite, so that we can be able now to use them in if maybe we are given the quadrilateral that requires those properties. So here, the properties that you need to know about the rectangle is that if we are given this quadrilateral ABCD, the rectangle, you need to know that the opposite sides of a palm are equal and are also parallel, just like AD is given that is parallel to BC, and AB is parallel to DC. Again, AD is equal to BC, and AB is equal to DC. Okay, fine. Now we come to the diagonals. Diagonals, they are the same as parallel. And then we also have opposite angles of a rectangle are equal, and they are all 90 degrees. Then now you can come to this inner angle. Since AD is parallel to BC, you can say D1 is equal to B2. Alternate angles, you state your parallel lines, and A1 is equal to Oh, hi guys, I'm sorry. Me out of the lesson. I assume it's my network is not that stable. Can you all hear me?
Yes, sir.
Yes, sir.
Oh, where my friend? Can you guys hear me?
Yes,
Oh,
sir.
okay. Thank you, guys. I'm so sorry, guys. Let me quickly share it. This. So I was asking you guys if these properties of a rectangle do they make sense to everyone?
Yes, sir.
Oh, okay. So we are having these two condition A and B. They are saying in order for you to prove that the quadrilateral is a rectangle, you need to prove one of the following properties. If then that quadrilateral So you can improve the that is a parallelogram. So I'm sorry, guys. I don't know what's happening with my network or my device, but it's keeping on kicking me. Property. The second property is saying opposite sides of a rhombus are equal, and all sides of a rhombus are equal, meaning AD will be equal to DC and equal to CB or BC, and also be equal to AB. And then now you can say the diagonals of the rhombus, they bisect those angles that they meet the outer boundary of a quadrilateral, meaning D1 will be equal to D2 and C1 will be equal to C2 and so on with the other angles, other corners. And then the last one is that where the diagonals intersect, they intersect at the angle of 90 degrees. There will be that perpendicularity at the intersection of the diagonals. Does this make sense to you guys?
Yes, sir.
Oh, okay. Thank
Yes.
you. Then we also have even, okay, thank you guys for the feedback. I love hearing that as always. So even with the rhombus, we have these two conditions, condition A and B. No, stop. Oh, I just don't know what's happening, but this starts to bore me. I'm suspecting me a lot. Oh, why were we were here. So are you guys fine with the rhombus?
Yes, sir.
Yes, sir.
Yes, sir.
Mm. Are they still there? Oh, okay. Thank you, guys. Then we can just proceed. Okay, thank you. Thank you for the feedback. I'm so sorry, guys, for whatever that has been happening. Okay, thank you. Now we can proceed to the square. The square is the same as the rhombus. It's just that the square now, the interior angles are going to be 90 degrees. degrees. 90 degrees. Angle A will be 90 degrees. Angle D will be 90. C and B will also be 90. Otherwise, it's the same as the rhombus. Even at the intersection of the diagonal will be right angle. Okay. Then we can go to the next one, trapezium. The following is properties with the trapezium. Those horizontal ones that are parallel and not equal. AD and BC, they are only sides that are parallel with the trapezium. And then now you can just come to the conclusion that D1 is equal to B2 because of that Z shape, alternate angles. Then you state your parallel lines. And D1, D1, you said that, and A2 is equal to C2, alternate angles, because of those parallel lines. Those are the only properties that we are having with the trapezium. In order for you to prove that the quadrilateral is a trapezium, you will need to prove only that AD is parallel to BC. Then you are done with the trapezium. Then you can proceed to the last one, which is the kite. So if ABCD is a kite, you may assume the following, that those upper lines AB and AD are equal, and those bottom one, BC and DC, are equal. And then that horizontal diagonal, it is being bisected by the vertical one. Therefore, BE will be equal to ED. Then the intersection of those diagonality at the intersection. Then now we have those angles C1 and C2, they are equal, and A1 and A2 are equal. And then opposite angles, those ones at the horizontal diagonal BD, they are equal as well. That's only what you need to the exercises. Are you guys okay with those properties so that we can go to the problems?
Yes, sir.
Okay, thank you. So we have the exercise 4. Is my zooming okay, or should I zoom in or out a little bit? Is it okay? Hey guys, is my zooming okay?
Yes, sir.
Yes, sir.
Oh, okay, okay. So exercise 4, number A, we are given that PQRS is the rhombus. Okay, now we know what the is that all sides of a rhombus are equal. In this case, PS is equal to PQ is equal to QR and also equal to SR, okay? And we know that PS is parallel to QR and PQ is parallel to SR. Therefore, okay, let's see what else we are given. We are given that S2 is equal to 35 degrees. Now we are required to calculate the size of all interior angles. Is there anyone, guys, who have idea of how we can calculate the in all interior angles of this rhombus? Is there anyone of you guys? Let me just go to my pencil. And then, okay, just like that. No. Are you guys still there?
Yes.
Oh, okay. Is there anyone of you guys who have got some idea of how we can calculate the size of angle R, angle Q2, Q1, angle P, and angle S1? Using the properties of a rhombus, because now we are given that PQRS is a rhombus. Using those properties of a rhombus that we just went through, Oh, avoiding to waste some time, guys. Okay, we know that the opposite sides of a rhombus are parallel. So PQ is parallel to SR and PS is parallel to QR. Therefore, we can see that here. Do you guys agree when I say angle Q1? I'm sorry, angle Q1 here is 35 degrees. Do you guys agree?
Yes, sir.
Yes, sir.
Okay, yes. Yes, thank you guys, because this line is parallel to that one. So they form this just shape here. Okay, now we have this angle as 35, this one. So I now say, do you guys agree when I say to you this angle is 35 degrees?
No, sir.
Oh, this. Disagree. I didn't hear well if that was a yes
I
or
disagree,
no
sir.
when I was asking you. Pardon?
I disagree, sir.
Oh, okay, then I think you should disagree with some statement that you think maybe it might be correct. What's on your mind?
Sir, I didn't quite get that.
Sorry?
I didn't hear you, sir.
Okay, I was saying, do you guys agree if when I say this angle here, S1, this one, this one is 35 degrees?
No, sir, I don't agree.
Oh, okay. Why do you disagree?
It doesn't form that thingy, sir. Like they're not alternate to each other.
Oh, okay, yes. I agree they don't form that. But sometimes you just, okay, in order for you to work with something, you don't only have to uh, jail yourself with only the rhombus just because they said, oh, this is a rhombus. That is why I always advise you guys, okay, when you hear that part, hear that PQRS is a rhombus, you now go to your diagram and highlight. Now, what are the properties of a rhombus? Is that, okay, all sides of a rhombus are equal. This side is equal to that. This is equal to, they are all equal. Do you agree to this part?
Yes, sir.
Okay, thank you. And this is parallel to that. And this is parallel to that. Therefore, again, you agreed that Q1 here is 35, reason being alternate angles because of that Z shape, right?
Yes, sir.
Are you still there? Oh, okay. Now I'm seeing an isosceles triangle. Remember, an isosceles triangle is a triangle with two equal sides. If this side is equal to this side, I can conclude by saying this angle is equal to that angle. Reason being, angles opposite equal sides. Therefore, I'm asking you now, is PQS not an isosceles triangle?
It is, sir.
Now, do you agree or disagree when I say, do you agree to my statement or not when I say angle S1 is equal to 35 degrees?
Yes, sir.
Oh, okay, thank you. So this will be 35. This and this will both be 35 degrees. Then, okay, this one as well, because of this side and this side, this will also be 35. Okay, because of that isosceles triangle, QSR, or you can say the base of isosceles triangle, or the angles opposite equal sides, QR is equal to SR. Then now, because of these parallel lines, these are parallel lines, they form that U shape from Ness's fan technique. And we already have this angle, that 35 and 35, which is 70 degrees. Therefore, this angle will be 180 degrees minus that 70 degrees. Reason being cointerior angles. Then you state your parallel lines. PS is parallel to QR. Does this make sense to everyone? Oh, okay. The last one, you can go to P. P is equal to R. Opposite angles of the rhombus are equal. Then you are done finding all the interior angles of this rhombus. Does it make sense to everyone, guys?
Yes, sir.
Yes, sir. Yes, sir.
Oh, okay. Are you guys sure?
Yes, sir.
Yes, sir.
Oh, okay. Thank you, guys. Thank you. Then I can just remove that. Now, number B, having number B there, they are saying diagonals AC and BD intersect at E. And then we are given that ABCD is a rectangle. Now we come by reading that. Now opposite sides of a rectangle are equal. Okay, and this will be equal to that. What else? This is parallel to that, and this is parallel to that. Okay, therefore, if that's the case now, using our analysis, we can come to the conclusion by saying that this angle is 20 degrees. This angle there will be 90 minus 20, which is 70. Why? Because this angle as a whole is 90 degrees. It's one of the properties of a rectangle. And then now we can say if this angle here, if this one is 70, then this one will be 70 as well. Okay, then you can play around your maths or the properties of a rectangle to fill everything there. Now let's go to the questions. I would always advise you guys to highlight everything that you know about the properties of a certain quadrilateral. Then now you can go to the questions and see what you are being required to find. So now they are saying calculate the following. Angle A1, there is A1, okay, we can get that. A2, we can get that. And then B1 is here, B2 is there, C1 and C2, D1 is there, okay, and AD, okay, and AB, okay, that. So, is there anyone, guys, who have got some idea of how we can calculate the size of angle A1? Using some properties of a rectangle. Is there anyone, guys, who can give this a try? Are you guys still there with me?
Yes.
Yes, sir.
Oh, oh, okay. I believe, guys, maybe this might be a bit tricky since you are quiet. Let me just not waste some time and just a rectangle, diagonals of a rectangle as the diagonals of these quadrilaterals, A by other, this will be equal to that. BE, E will be equal to BEC. So now what can we do to find angle A1? There is angle A1. What can we do now to find that angle A1? Let's see. So we're given BC as 8, D2 as 20. So I don't think the order matters. You can just quickly jump to what you can find. So we can find now, we can go for this one, B1, okay, and say that B1 there is 20 degrees, reason being alternate angles, AD is parallel to BC. Do you guys agree to that?
Yes, sir.
Oh, okay. And what can we think we can find B2? Okay, this whole angle, one of a rectangle A as a whole, B2 will be 70 because that's 9. Okay, you're fine with B2 here. This, we found it 70. Let's agree that. Oh, this thing has started again. My apology once more, guys. Let me share my screen and go back to the document. Oh, we were here. I was asking if you guys agree when I say B2 is 70 degrees. Do you guys agree to that?
Yes, sir.
Yes, sir.
Can you guys hear me? Maybe I need to. Oh, okay. Thank you, guys. Oh, okay. So now D1, we can find D1. Okay, this is D1. Alternate angles, it alternates with this one. So it's 70, that one as well. Or you can find it by saying this 90 here. You can just say this 90 minus that 20, you get that 70 there. Okay. And then now, what are we left with? C1, where is C1? What now can we do? Okay. Anyone with an idea, guys? You can just help me there on how we can get those. And we have this. Left with those ones there. Okay, we said this is equal to that. And then we said this is equal to this. And this is equal. Please agree when I say to you, triangle ADE is congruent to triangle BEC. Side, side, side. Her. Are you guys still there? Do you guys agree with that statement that I've just said? That triangle this is my D, maybe it was hidden. I said ADE is congruent to BEC. Do you guys agree to that statement?
Sir, can you please repeat the triangle name?
Yes, sir.
Oh, I said ADE is congruent to BEC.
Yes, sir.
Oh, okay. Then
Yes, sir.
if that, oh, okay. If the case, we can say maybe because now we don't know. Okay, since you agreed, maybe I can remove this. You agreed that these triangles are congruent. And in these triangles, we have this angle. Okay, these are the triangles of the focus. And then we have that angle there. Now, when we let this angle be x, maybe the other angle will be the third angle of the triangle. And what else are we having? Oh, we had that this and this are equal and these are equal. What can we conclude here? I'm a little bit lost. I don't want to assume that this angle is equal to that angle without having any reasoning. Is there anyone, guys, with some idea? Because now, I'm lost. I can't continue. We found B1 and B2 and D1. Okay. Oh, guys, can I just please skip this question? Then we just start with this question on our next lesson. Let me just continue to the next part of tonight's lesson. Please, guys, remind me to just start with this question on our next session, okay?
Yes, sir.
Yes, sir.
Okay, thank you, guys. Then with the rest of the problems, we will just use those properties. That number C problem, number D is a rhombus, you use the properties of a rhombus. E, you use the properties of a rectangle, and so on. So there's also this other part I want, because now we just did kite, rhombus, trapezium, and then we did a parallelogram. So now we are just going to just delve a little bit deeper in these polygons. I think I won't touch this paragraph here because it's summarized here on the table. So what I will do, I'll just go through the table. I will leave this part out. So we've got these polygons. The first polygon that we are having is a triangle. Triangle with 3 sides. They are saying this is a regular polygon. Maybe the basic of a triangle is an equilateral triangle. Then they are saying the sum of the interior angles is given using this formula here, 180 degrees times n minus 2, where n is the all corners of the quadrilateral or the polygon. So the interior angles of a triangle will be given by this formula, and we said n are all corners of the quadrilateral. So in this case, the triangle have got 3 corners. It will be 180 degrees times the 3 corners minus 2, which gives us 180 degrees. So the sum of all the interior angles of a triangle is 180 degrees, and we know that. And then now the size of the interior angle of this equilateral triangle will be 60 degrees. So does this part make sense to you guys?
Yes, sir.
Oh, okay. So now you can come to a conclusion that in any polygon or quadrilateral with 3 corners, you need to know that all the sum of interior angles add up to 180 degrees. Okay, we are done with that part. Then you go to four sides. Four sides, polygon, four sides, a square, a rectangle, parallelogram, trapezium, a rhombus. Those are polygons with four sides, four corners. Okay, basically the square, the sum of all interior angles will be given as 180 degrees times that four sides or four corners minus 2, then that gives us 360 degrees. So now we know that if we encounter some problem with the polygon or the quadrilateral with four corners or four sides, we know that the sum of all interior angles of that polygon is 360 degrees. Then the size of an interior angle in that thing will be that 360 degrees we divide by the number of sides there, which is 4. Then it gives us 90 degrees. So does this part make sense to you guys?
Yes, sir.
Yes, sir.
Oh, okay. Then, oh, okay. Thanks for the feedback, guys. So now this gives us the confidence to say that, okay, if the shape, the quadrilateral or the polygon have got four sides or four corners, the sum of all interior angles, they will give us 360 degrees. Same applies with the five-sided one. Pentagon will be given as 180 degrees times five sides or five corners, which is now adding up to 540 degrees. And hexagon as well will be 180 degrees times that 6, because it has got 6 sides or 6 corners, minus 2. Then that one will add up to 720 degrees. Then you can go to the last one, which is the octagon. Gone 8 sides or 8 corners, then that one will be 180 degrees, gives us 1080. That makes sense to everyone, guys, because we have sizes. Does it make sense to everyone, guys?
Yes.
Okay, thank you, guys. Then we have got number A here, exercise 5. We are saying A, B, C, D is a polygon. And then they didn't specify what kind of a polygon. Now they didn't specify whether this is a trapezium, parallelogram. They just said it's a polygon with four sides. Oh, that's a powerful information that we can use with four sides. And then now they are saying to you calculate the value of x. Then we can see that angle have got x, this angle have got x, that angle have got x, that angle have got x. So now we are required to find that unknown x. Is there anyone of you guys who can share some idea of how we can find that value of x? Is there anyone, guys, who can share some idea? Are my friends still there? Are you guys still there?
Yes, sir.
Oh,
Yes, sir.
okay. I think maybe you are still trying to think on how you can approach this problem. Or maybe you are shy. I don't know. Are you guys maybe still trying to figure out? Okay, yes.
Sir, can we say B is equal to D?
Oh, what's the reason behind that?
Isn't opposite sides are equal? Opposite angles are equal.
Opposite angles of what, maybe?
So I don't know. I don't know what shape this is.
Oh, okay. Good try though. Good try though. That can work only if you are given that. Oh, this quadrilateral is a rectangle or a parallelogram or a rhombus, because those properties you are sure that opposite angles of those three quadrilaterals are equal. So this is just an anonymous quadrilateral or a polygon with only four sides that you are given. So you need to be sure that this is a rhombus, this is a rectangle, this is a quadrilateral, this is a parallelogram, in order for you to conclude that opposite angles of this palm, this rectangle, this rhombus are equal. I don't know if this makes sense to you.
It does, sir.
Are you sure?
Yes, sir.
Oh, okay, thank you. If maybe you are not sure, it didn't make sense, don't be shy to just shout out where you didn't understand. But with this, you are just going to use these properties that we are given in this table. But okay, that is why I said this is a powerful information, a polygon with four sides. Okay, then you know we went through this part. I will just take a shot of this table, guys. I will post it in the channel there because you will need this. It will help you a lot. So they said that polygon have got four sides. We now are going to need this part. We are going to need this part. Now we know that the sum of all interior angles of that polygon, because it has got four sides, so it is going to give us 360 degrees. So what you are going to do with that one is that you're going to say angle A plus angle B plus angle C plus angle D is equal to 360 degrees. That is the properties of a polygon that has got four sides. Do you guys understand this part?
Yes, sir.
Oh, okay. And then now you substitute your angles. What is the angle A? Is 8x plus 2 plus what is B? B is 4x plus 2 plus x minus 2 and then plus 5x minus 2. That will be equal to 360 degrees. Then you solve this equation by collecting left terms. You leave all the x terms on the left-hand side. You transpose all the constant on the right-hand side until you solve for the value of x. Then you will be done just like that. Does it make sense to everyone, guys?
Yes.
Are you guys sure?
Yes, sir.
Yes, sir.
Oh,
Yes.
okay. Okay, thank you, guys. Now, number 2 is now requiring us to show that ABCD is a trapezium. Now, I said to you guys, in order for you to prove that part A maybe it's a car, you need to know the properties of a car. If you are required to prove that the quadrilateral is a parallelogram, you need to know the properties of a parallelogram. Now, in this case, we are required to show that ABCD is a trapezium. Therefore, we need to know the properties of a trapezium. We saw the properties of a trapezium here. It's not much. It was just 2 lines. Here they are. So this is only what we need to know. Opposite sides, I mean, not only those horizontal sides, AD is parallel to BC. That's the only thing we need to show. So, and then they are saying here, in order for you to prove that the quadrilateral is a trapezium, you will need to only prove that AD is parallel to BC. That's all in order for you to prove that something is a trapezium. Does this make sense to you guys?
Yes, sir.
Okay, thank you. Then let me go back to the problem. What is the problem? This is the problem. So we are required to just, in order for us to prove that this is a trapezium, we need to prove that those horizontal lines are parallel, which are this one. We just need to show that these lines are parallel. So is there anyone? Let's say now we found the value of x as something. Maybe the value of x is a. So it's a, yes, a. So is there anyone, guys, who maybe can give us an idea of how we can show that this is a trapezium?
Sir.
Yes.
So, sir, after we calculate the angle, the value of x,
Yes.
so can we use like it doesn't seem like it's gonna work, sir, because we don't have a diagonal.
Or you can give it a try and share what's on your mind. We won't judge. What is on your mind?
So I was gonna say that if we can prove that maybe angle B is equal to angle D, then we can prove that AB is parallel to DC, and then we can prove that it's a trapezium.
Oh, okay. But a good try though. Thanks for that. But you can also use, okay, can't you see something here using this technique? This is not 100% hint, but this will give you some hint. Using this technique, can't you extract something here? You know that this only applies to prove that some lines are parallel or to find angles if there are some parallel lines.
Yes, sir.
So what do you think this can help us with?
So we can use co-interior angles to prove that they are parallel to each other, the sides.
Yes, 100% correct. Now, after finding the value of x, you can just come to angle B plus angle C. Now you know the value of x. 4 times whatever value that you got of x plus 2. Then plus that angle C. C is 5 times whatever value of x that you got minus 2. Then, now if when you simplify this, you get 180 degrees, you can come to the conclusion that AB is parallel to BC, that your reasoning being the converse of cointerior angles. Then you state those equal angles. Then now, if we have shown that AB is parallel to DC, then ABCD is a trapezium. We are done just like that. Does it make sense to everyone, guys?
Yes, sir.
Are you guys sure?
Yes, sir. Yes, sir.
Okay, guys. Okay, guys. Thank you. Then what I will do, I will just take a screenshot of this part. This part is very important, guys. This table. I will send it there in the channel, as well as these properties of these quadrilaterals for you maybe to have a look on them some other time you wish to. Then now, same applies with this one. You can see number B is a pentagon. You are going to use the properties of a pentagon from this table. Same applies with C. There is a parallelogram, and that triangle will just work around those polygons. Then now, the last section, is it the last section of Euclidean? Let me just check. But you're almost done with Euclidean, guys. Yes, it is the last section. This is the section I will emphasize the most. We're gonna do it now and on the next session. So I will also advise you guys to ensure that you understand this theorem because it will also be there in grade 12 next year. You will find it. So they're saying the midpoint theorem in a triangle. The midpoint theorem can be stated in the following two ways. Am I still audible that side, guys? I just want to ensure before I can go far.
Yes.
Yes.
Can you all still hear me that side?
Yes,
The
sir.
midpoint theorem can be stated.
Yes.
Okay, thank you, thank you. Thank you for the feedback. I appreciate it. I love hearing those feedbacks. The midpoint theorem can be stated in the following two ways. We have got this triangle on the left, which is this one. We've got this triangle, we've got this triangle. Those are the two ways the midpoint can be stated. Okay. So the first triangle, they are saying if you are given that AD is equal to DB, and you are also given that AE is equal to EC, you can come to the conclusion that DE is parallel to BC, and this DE is the half of BC. Does this make sense to you guys?
Yes, sir.
Okay, guys. Please, guys, if you don't understand, just shout it out. I don't mind repeating this. I will repeat it. This is very, very important to you guys. It will be there in grade 12. So, okay, let's go to the other triangle on the right. ABCD, ABC, and D is parallel to BC now. They are saying, if you are given that AD, in this case, AD is equal to DB, only this side on AB, and then now you are in this one, you are not given that. This is equal to that. You're not given that. You're only given that this is equal to that. Okay. And then now in this case, you are also given that this line is parallel to that one. Then with this one, you can come to the conclusion only if you are given that this is equal to that and this line is parallel to that one. You can come to the conclusion that now this one is equal to that one. And this one is the half of this one. Does this make sense to you guys?
Yes, sir.
Okay, I hear the feedback from one person. Does it make sense to the others?
Yes.
Yes, sir.
Are you guys sure?
Yes, sir.
Yes.
Okay, guys.
Yes, sir.
Thanks. Okay, now let's go to the exercises and see if we can apply a midpoint theorem to calculate what we are required to find using this midpoint theorem. Exercise 6, number A, they are saying triangle ACD. ACD. Oh, that's our triangle right here. This one. Okay. And then they are saying, they are given that. Well, let me just highlight that. AB is equal to BC. This is equal to that. Okay. That is very important. And GE is 50. Alright, guys, I'm back. This thing has started again. So, guys, do you mind if maybe I know now it's almost 8 o'clock? Do you guys can maybe log out of the lesson at maybe 10 past 9 just to cover up some time that we've missed?
No, sir.
No, sir.
You guys appreciate it for allowing me to just use extra time. Now let's just go back to problem. So we had this problem here. So I was asking guys if there's any one of you maybe who can share some idea of how we can approach this problem. Is there anyone, guys? Okay, I believe this might be a little bit challenging. Let me just work it through. Excuse me. So we were given that we know that the midpoint is like this. If we are given a triangle A, B, and C, such that this, okay, this is E maybe and F. AE is equal to BEEB, and AF here is equal to FC. And then we are also given that this is parallel. No, okay, I'm sorry. I'm being mistaken here. If we are given that this is equal to this and this is equal to this, we can come to the conclusion that this line is parallel to that one, and this is the half of this. So here we are given that this is equal to that, and this is equal to that and that. Let me just use maybe blue color for that whole side. They are all equal that side. So now we are also given that, what are we given? We are given the length of this GE as 15 centimeters. So when we come to the triangle ACF, do you guys agree when I say BF is parallel to CF? Are my friends still there? Let me just check.
Yes, sir.
Oh, yes, they are still there. Oh, okay. Thank you, guys. So I was asking you if you guys agree when I say BF is parallel to CE. I mean, BF is parallel to CE. Do you guys agree?
Yes, sir.
Oh, yes. Thank you. Then now, this is parallel to that. Reason being midpoint theorem. And then we know that this is the half of that. So now, when we come to this triangle BFD, it's like this. It's like this. We have this line. We have shown using that ACF triangle that this line is parallel to this one. This is B, this is F, this is E, this is D, this is G. Okay, and we are given that this is equal to that. Therefore, if that's the case, we can just come to the conclusion that this is equal to that midpoint theorem. Do you guys understand that part?
So will you please repeat again?
Oh, okay. I'm sorry, I've got a flu, guys, this side, but let me just repeat. So you understood why I said these blue lines here are parallel. Did you understand that part?
Yes, sir.
Oh, okay. If now those lines are parallel, okay, let me just extract this line. I'm just avoiding to make a mess to that small triangle there, guys. We have B, we have F, we have D, and then we have oh, G. G is here, and then we have what? E here, E here. Using that triangle ACE, we have proved that this is parallel to that. You understood this part, right?
Yes, sir.
Okay. Now we are given that this is equal to that. This is this information here. We are given that. Using midpoint theorem here, we are using this triangle, this one here, that if these lines are parallel, and when you go to this line, this is equal to this, you can come to the conclusion that this is then equal to that, and this is the half of that. Do you understand this part?
Yes.
Okay, thank you. Then coming to this one part here. Now, if this line is equal to this one and this one is parallel to that one, we can say this is equal to this one, midpoint theorem. That's my reasoning. This is equal to that. That is midpoint theorem. And on the midpoint theorem now, we know that this is the half of this. Therefore, if in this triangle of ours here, it might be a mess, guys, but I hope you will see this. We were given that this is 15. Therefore, midpoint theorem in this triangle will give us this line here as 30 centimeters, because this is the half of that is the midpoint theorem. Does this one make sense to you guys?
Yes, sir.
Yes, sir.
Oh, okay, thank you guys. Then let me just use maybe a green color. Also on this one, we've shown that midpoint applies, and we've shown that this line is parallel to that one. We were given that this one here is equal to this one. We were also given that this one is equal to this one. Therefore, this side that we are required to find, which is CE, will be 2 times this one here, midpoint theorem. Therefore, if this was 30, this here will be 60. Then you are done finding what you were required to find. Does it make sense to you guys?
Yes.
Yes, sir.
Are you guys sure?
Yes, sir.
Oh, okay, guys, that's what I can say we're done for today's lesson. Is there any question regarding what we just did today?
No, sir.
Oh, okay, guys, and thank you. I'm now logging out of the lesson. But please, guys, on the next session, just remind me to just start with that question of the rectangle I left out there up there, so that we can just finish off with the Euclidean geometry and then move to the next chapters. Otherwise, thank you guys for being with me tonight. And once again, my apology for those cutting offs that I've been being kicked out of the lesson. I'm sorry, guys. I'm now moving out of the lesson.